Well, good morning, good afternoon, good evening. From wherever you're joining us today, we are now live. And wow, what a pleasure it is to see this webinar blossom into a truly international event, attended by, just checking the numbers, over 200 people from around the world. And why not? When you have a speaker of the caliber of Dr. Reddipogu, it's no surprise to me that it's generated such excitement. Let me introduce myself. My name is Ben Jenkins. I'm the Managing Director of NobleProg UK, Ireland and Netherlands. And we are delighted that you can join us for this fascinating webinar, AI, the Imprecise Science, Smart or Stupid, with Dr. Reddipogu. Just before we start the webinar, there's time for me to tell you a bit about NobleProg. We started back in 2005, and we've been delivering leading edge technology training all over the world ever since. Our business is built on integrity and quality, a combination of internationally recognized certifications, professional skills development, and bespoke course content, all delivered by trainers with real-world experience. We love running these webinars as a way to showcase the impeccable quality of our trainers, of course, but also to reach out and make learning accessible to all. We have a real mixed audience today of seasoned AI professionals, but also the new, the aspiring, the next generation of experts. Welcome one, welcome all. It doesn't matter where you come from or what your background is. We want to be part of a skills development sector that is open to all. Now, you've heard enough from me. To the main event. I wish you all very well. To introduce Anne, I'm very pleased to pass you over to my colleague in the Netherlands, Dr. Natalia Mogles.
Dr. Reddipogu is a multidisciplinary professional with a PhD in artificial intelligence and experience in information systems and mechanical engineering. In this talk, Anne will share her pursuit of intelligence and share her vision for the future of AI.
My name is Anne, which is ANN, short for Artificial Neural Network, which is a foundation of artificial intelligence, as you all know. So I was probably, born for this, but hopefully I'll be able to take you through a journey of AI, the past, present, and future. So let's get started, and let me share my screen with you so I can take you on a journey of AI. So this is the landscape of AI. As Ben and Natalia have said, we have a very broad audience today, joining us from all over the globe, different age groups, different backgrounds, different ideas about AI, different expectations from the subject of AI for future applications as well. So we're just going to keep it quite broad in some sense, but also dig deep where we need to and ask the questions so we actually lay the right path for future generations. So let's get started. AI and imprecise science. Let's dig deep and find out if it's smart or stupid. So this is the landscape of AI, the top 100 companies that are currently quite active in AI from 2020. If you see with the healthcare, retail, government, planning, sales, CRM, R&D, cybersecurity, you name it, it's touching every area, every sector. Now we have one from 2021 and the landscape is changing. So healthcare, many of the companies have actually dropped out, new companies have come in. And this again is dictated by the results they're getting in these areas, the funding that's going in these areas. And of course, these 2 years are also COVID years. So, that has probably dictated the developments in this area a little bit. Now, with all this interest in AI, let's actually go a bit deeper and actually see what the current situation in AI is. So this one here, for example, is from 2015. Google tried to actually predict flu trends based on all the searches through their search engine, and they failed spectacularly. So in 2013, it failed by 140%. Now, one of the things I have to tell you, yes, we are starting on a very, very pessimistic note. Like, here's this new technology, here's AI, it's just all singing, all dancing, it's going to take over the world. And I start off with this news saying even Google couldn't actually get its flu prediction right with all of the data that it has. Well, that's probably because I live in Scotland, and there is a thing in Scotland that we say, which is this pessimistic Presbyterian views we have. Look at us, it's so sunny here, but if I'm going out, I definitely would wear a jacket and take an umbrella with me. We are well prepared here in Scotland. But it is important to actually not look at just the successes, but also the failures. And that will give us a good idea on what further research needs to be done, where we are at the moment, and why we are at this stage. What is happening with technology that, that they got this wrong. So the next thing is Google's AI health screening accuracy also failed. This is April 2020. They were trying to predict diabetic retinopathy. They had a good success rate in the laboratory, but by the time they took it to the field, again, it failed. They did not get the accuracy that they hoped they would get. And the next slide, Facebook head of AI says, we've hit the wall in terms of AI, that kind of reached a sort of dead end, if you like. So let's see why this, is this all there is? This is 2019. So we now saw 2019, 2020, 2015. So over the last decade, if you like, these big companies doing the research with world-class resources, especially the amount of data that they have, it has completely got things wrong. So what is happening? Why is this happening? And where is this? Is this what it is? Like, what is AI? Is it smart or is it stupid? I mean, those systems must be pretty stupid that they actually got things wrong. They couldn't predict them. So that's what we will look at today. That's our question, and that's what is important to actually look at, whether you're a researcher or a consumer or an investor or a venture capitalist who is trying to fund an AI startup. Let's look at it. Let's see what we can do further. So the search of intelligence, where did it all begin? What was the landscape? Where are we today? Now, in the 1950s, there was this big idea saying, let us invent machines that are as intelligent as humans. Let's have human-like intelligence. But now we never got to the human-like intelligence, as you all know. And we actually haven't even reached the intelligence of a fly, perhaps. But we have made advances in the field. And some of the advances have led to many, many, many products that we currently use and enjoy and are developing even further. Now, more recently in the landscape, we have actually heard quite a lot about deep learning as well. So we'll look at some of these areas. So nowadays, there are these differences definitions that people are trying to create with machine learning, data science, artificial intelligence, and everything else. But for the purposes of this talk, we will look at it as any data that has to be analyzed with some sort of intelligence, whether that intelligence is low-level intelligence, high-level intelligence, whatever you would want to call it. And towards the end, we may also try to define what intelligence actually is. What is the definition of intelligence? we have reached a certain level of intelligence that we use on a daily basis. So let's have a look at some of these. So we have here a few different things: optical character recognition, political campaigns and prediction of elections. We have recommendation engines such as Amazon and things. We have autonomous vehicles. We have, face recognition systems that are being studied and so on. So the first thing, let's look at this political campaign, the elections. As you know, those are not extremely good either, because we got Trump's election completely wrong. We couldn't predict that he was going to win. They all predicted that Hillary Clinton was going to win with the American elections. So something is going on there that we need to dig deeper. I will look at some of the other ones in here. Autonomous vehicles, we will touch on that as well a little bit as we go along. And we'll look at another amazing product that we all know, and which we'll have a look at right now, which is Amazon. So let's actually look at AI in action. Now we're going to go into Amazon, try and order a yellow rubber duck. Okay, so let's see what results it gets. Yellow rubber duck, fine, yellow rubber duck. Here we have some yellow rubber ducks with pink ones. And further down, we have more yellow ducks. Here we have pink and white rubber ducks. We have a green rubber duck. These are sponsored ones though, so let's leave them. They're just ads. So here, if you see, I asked for a yellow rubber duck. I was searching for a yellow rubber duck, but I got a pink, red, and white rubber duck combo. Let's go further down. There are some yellow rubber ducks here, so we'll accept that. Go further down. Next page. I have a red sort of dinosaur sort of rubber duck. And here I don't have a rubber duck, it's given me some fish. Bath sharks. And then I have a white one, and I can keep going, and I have a black one here. So what does that show us? The most intelligent recommendation engine, Amazon. We all say how intelligent it is. It gives us the results straight away. But we just saw it. I'm just trying to order a yellow rubber duck. And I got a pink one. I got a black one. I got a green one. I got, white one. So is it intelligent? Anyway, why do we need to use AI in this instance? Do we actually need AI? Is it necessary? There's another black one here. If, for example, I had used just rule-based algorithms, so if I say if yellow, I bet I wouldn't have got black rubber ducks and pink rubber ducks and other ones. By the way, I should have told you right at the start that I am going to use very simple examples, because it's through simple examples that we can actually understand the concept of a more complex intelligence. Now, if you go into Amazon Science, it actually says that it uses deep learning. Deep learning is one of the advanced artificial intelligence methods. Now, why on earth is it giving me fish when I ask for a duck? And why on earth is it giving me something red and black when I'm asking for yellow? So something is going on there that we need to address. And again, when we don't need to use AI, do we need to use AI? In this particular instance, just if-else rules with operators, logic operators, such as and or, should do the trick. So if I say yellow, only those products with a yellow should come up. And if I say rubber duck, only rubber duck should come up, not fish, not dinosaurs. So let's go back to our presentation here. So we just saw the most advanced tech company in the world, who are going to take AI by the storm, who also recommend or give machine learning options in their Amazon Web Services, cloud technology. We demonstrated AI in action with Amazon's buying a yellow rubber duck. And we now start to question what intelligence is all about. So the recommendation engine, it says, if a customer is buying a brown shoe, give him another brown shoe, recommend another brown shoe. How difficult can it be? How intelligent should a system be for us to be able, for the system to be able to recommend a brown shoe? A rubber duck, here's some more rubber ducks you can actually buy. Pardon me, you want to buy a sofa? Here's some more sofas. In fact, that's what AliExpress, eBay, and Amazon all do. We don't need, it's a lookup table. We don't need AI in some instances. And when we do use AI, sometimes instead of a yellow rubber duck, we end up with a black rubber duck and a red one and a green one and a blue one and a white one. Let's go further and see, why is that? We looked at Google, we looked at Amazon, we looked at what Facebook was saying about these three big tech companies who are very much into AI, who you know, are pumping in billions of pounds into AI products. So where did it all start? What's this new wave of products coming into the market, of technology techniques coming into the market, that's sort of driving the research forward? So it all started with big data. So as the search engine, Google search engine started, we started having more and more data, and that data has driven quite a lot of the advances in this field. So this is a prediction from Cisco from 2011, and it said by 2020 we will have about these are the number of people, the world population, but we will have 50 billion connected devices. That is about 7 devices per person. This includes Fitbits, any wearable tech, and so on. And all of these will be talking to each other, passing information to each other, and contain data and transfer data. Now, what kind of data are we talking about, and what are the problems of the data? One is the volume of data, and 2 is the velocity with which the data is being streamed, and 3, it's the variety of data and the veracity. The veracity is quite important. It's the uncertainty of data. So poor data quality, if you see here, costs the US economy $3.1 trillion a year, which is quite a high number. 1 in 3 business leaders don't trust the information they use to make decisions. If they don't trust it, how can the consumers trust it? If you see the velocity of the data, about 100 sensors are in modern cars. But if you take something like Tesla, they probably have even more than 100 sensors. So you can see the amount of data we are having to deal with, or the amount of data that is actually available. That's quite wonderful. It's quite wonderful for AI. It's quite wonderful that AI has all this data that they can use. And that's why there are advances in AI that are difficult to contain right now. So let's look at it in actual numbers. Like our laptops are about 1 terabyte. If you keep going further, it's petabytes, exabytes, zettabytes, and yottabytes. So the NSA storage capacity in 2013 is 1 yottabyte. That's one organization. All the data recorded in 2011 is 1.8 zettabytes. That's just 1 year. And now it's even higher. If you go through an airport, for example, they're taking your fingerprints, they're taking your face, picture of your face. If you go through the airport 10 times, 20 times, it will, you know, and each of these images is about several megabytes. You know, even if it's kilobytes, it will all end up as just with one person, several terabytes. So what is it that has, you know, what is it that the drive for generation of this data? How come we have ended up having so much data, and how is this data useful or not useful in terms of the developments in AI? So let's look at the current developments. We have cloud technology, because all that data has made advances in cloud technology possible. We have deep learning, convolutional neural networks, and we still are tackling with the imprecise nature of neural networks. And we will then do a SWOT analysis. So we'll actually look at all of these little pieces of the jigsaw puzzle that are important for the advances in AI. That's actually currently happening as well. Now with the cloud, I call it a data junkyard. One, it's environmentally unfriendly. Every bit of a cat video I take, the video of my dog, the video of the cheesecake is all ending up in the cloud. The number of versions of my presentation is in the cloud. Now, I put to you that no cloud, heaven or hell, can contain the amount of data we're generating per day. So it has become a data junkyard. And if our AI systems are actually going to be using as much data, then we will end up having AI products that are environmentally unfriendly and worse than what cars can do to climate change. Greta, if you're hearing this, you know, get on the AI cause, because at the moment AI needs all of this data and we don't have renewable sources to, you know, hold all of this data. Basically, all these servers, the cloud are just, you know, rows and rows and rows of servers in Colombia and many other places that are holding our information. Also, there are laws related to it. So if you have German data being saved in an American server that is actually in Colombia, there's quite a lot of issues related to the law as well in that regard. Now, let's look at the next bit of the puzzle, which is deep learning. Now, again, here we have, I'm going to use simple examples, as I said. These are cats and dogs. We're trying to recognize and differentiate between cats and dogs, but this could be any complex issue, such as cancer, non-cancer, such as a threat, an obstacle, and one that, you know, faces. It could be different faces. It could be anything that we're trying to recognize, trying to differentiate between the patterns. So we go through a series of different processing units, layers and layers of processing units. It goes through several iterations, several loops. It adjusts its weights and it gives us a result. So we have processing units, we have layers of deep connections between these processing units, and we have a good or bad result in the end, we find the error, we go back through the learning process again, and it just continues and continues until we have a good result. Now, this is what our brains do. So we have neurons in our brains. The sensory organs take sensory systems in our body, take all the sensory stimulus, processes it in our brain, and then gives us a result. Now, this is generally what deep learning is all about, but there are other things, but we won't go too much into detail about it. But let's see what the results for this deep learning are. This is one from Nature. So if we have a stop sign, and then we have a system that recognizes stop signs, but then we add little stickers on, it says, it gives a bad result. The speed limit is 45. If we have images at the bottom here with abstract patterns, it's saying it's a king penguin. The other one is saying it's a starfish. Now further down, we continuing on that path as we tilt it. It's a stop sign tilted a little bit. It says a dumbbell. Even further tilted, it says it's a racket. A fly, dragonfly on a mat is seen as a manhole, and a mushroom fallen over is seen as pretzel. So it's really easy to fool a deep learning network as well. So other than that, because of how we use data and where we store it and how we access it, these systems are hackable, and we can see from our previous images that they are actually quite fragile and brittle. They break down pretty easily. Now, you give me any deep learning network developed by Amazon, Facebook, or Google, or anyone, I can destroy it in a second. It's not because I'm really good at it. It's because these systems are so fragile. So what is happening? Is it deep learning or deep confusion? Are there too many things going on within the system that is causing these systems to not perform as well as we would have hoped them to? So maybe there are a few problems. One is the data selection and pre-processing. With that part where we clean the data too much is probably causing issues. There's also too much data. There's too many layers and nodes, processing units, and it's too biased. So for example, if we take the data, if we have one which is elections, about elections, we're trying to predict what the outcome of the elections would be. And you take the age group of into consideration, the variable that's age. And if someone is there who is minus 300 or 3,000 years old, what we tend to do is clean it up. We take it out. But perhaps sometimes leaving in a bit of that error, not cleaning up as much, will allow learning to evolve. There are other things we can obviously do, which I will go through later on, but we do need to avoid this confusion that we're putting the deep learning system through. It is a lot of trial and error. As you can see, it's like how many layers do we use, how many processing nodes we should use, how do we interpret the results. It's all trial and error. And then when we don't know the answer, we'll just say, well, the AI system did that. I don't know how it did it. We can, of course, there are many companies, many researchers who are very good at bringing in details related to the system. To put it in plain words, details that are not quite taught in the public domain. So they can bring in their own expertise to make these systems more robust. but deep confusion is what is actually happening in most deep learning systems. So we are trying to find precision in a very imprecise science. We don't know how to set the architecture. We don't know how to set the iterations. We don't know how to give a fitness score. And we don't know how to actually decide on which bits of the data we have to keep. This is cancer images of cancer from lung, breast, and if you can see here, we can clearly see that this is cancer here. There's a tumor here. There's a tumor in the breast. There's a tumor. You can clearly see where the tumor is. Now we are using deep learning systems to actually diagnose cancers, but these are again done separately. It's not like a one size fits all. So lung cancer only, breast. So imagine if you have, if we're trying to develop a system with breast cancer, we have images of breast tumors, and there's only so many ways, so many locations you can actually find a tumor in the image. But it's still at a stage where early diagnosis is not possible. And even the ones that are currently being developed are not at a stage where we can actually deploy them fully. So again, the point of actually developing these is to automate it, automate what is actually a routine work for doctors. But early diagnosis is way far away, because if the AI system is getting this wrong, where we can actually see it, there is no way the AI system can actually make early diagnosis possible. So that is the IQ of AI right now. It's at a stage where it cannot make early diagnosis. 2, it's only doing what the doctors can easily do anyway, but that is still a good progress because the doctors actually get to free up their time for more other cases that are more difficult to deal with. But otherwise, it's not intelligent. It is like a lookup system in some ways. What is the concept of intelligence now? It's not doing more than what we expected it to do. It's only doing what we can already do anyway. And even that, not at 100%. So that was deep learning. Now let's look at convolutional neural networks. With convolutional neural networks, when I say deep, whether that was deep learning, of course, there's like loads of other things in there. You can have dropout and sequentials and all of that, but in essence, that's what it does. Convolutional neural networks, here we have an input image. These are used mainly for images. So for cancer, for example, tumor images, they're trying to use this. It goes through a series of convolutionals and pooling layers, and towards the end, it goes through what is another deep learning system, which is just a fully connected layer, which was like the one we saw before, and it leads to a prediction or not. So let's look at convolutional neural networks here and just have an overview of what it actually does. So what it, when we have an image here, let's say this is a grid with pixels of the image, and it goes through a convolutional part and then a pooling part. We won't go through it in detail, but let's look at just what it does, superficially. So we have the red square or filter here, or grid, and a green grid, and you have the brown grid, if you can see it all on your screens. What it does is it goes through that step by step, scanning almost all pixels in the image. And as it keeps moving, it tries to combine these and have an output for these images. The reason they used the system was because they thought the proximity of different features within an image was important to actually recognize the image. So if my eyes are right beside each other, it's important to take a snapshot of these eyes close together rather than go through that first and then come to it a bit later. Just have the proximity of these two features that are important. So it's the capture features that are right beside each other. It's a bit like high definition television. So if you have a newsreader and the background is blue, and then basically the pixels, when you combine them at the back, the blue background, you just get a blue, we just get blue. And they keep the face, which is the main part, a bit more crisp. So in this image here, as you keep going through, you convolve them, but you can see that as a grid. I mean, you don't have to be an expert at this, but if you keep moving the grid along, you will notice that some of them end up being represented far more than the others. So you have very few representation of the second vertical column, for example, whereas the inner ones would actually get more representation. So it's a pretty convoluted system in some way, as the name suggests. And then the next part, if you see, it goes to what's called pooling. And in pooling, there's again they just pool basically the data, and then you have an output. If you see here, with there's two different types of pooling that can go on. For example, one is called the max pooling, and the other one is average pooling. So here, of the green pixels, you have 100, which is the maximum of these four. So it takes 100, so maximum of those four. The maximum of the other ones in the pink is 184, and it goes there. The maximum of the other ones here in the yellow or brownish one is 12, and the blue ones are 45. The same with the average pooling. Once you average these up, 31, 15, 0, and 100, you get 36. You average the other ones in the pink, you get 80, and so on. So if you see here, 100 has become 36. And the one with 184 has become 80. Now, in some ways, this is very biased. If you take max pooling, and it's very flippant and sort of, I don't care what happens to the other ones that are quite high in the number, and it's quite flippant in the way it deals with that data. So despite all of this, they still work in the sense that we can still break them. Of course, they're still brittle and fragile and everything else, but they still work. Why does it work? Why does it work? Because what it's actually doing, despite all these convolutions and all this pooling and other things, and the numbers are basically changing quite a lot of the image. The reason it works is basically the AI is holding the pattern of information that is being fed through. So how much ever you actually destroy the image, you end up with a pattern that represents that image. And that is what is being fed through to the AI, which holds that pattern. So if you go back to our original image of these processing units all connected together, what's really happening is it's like a memory map holding the memory of all the patterns it has seen before. No matter what you have done to those patterns before, no matter how much you clean them, no matter how much you've convoluted them, no matter how much you put it through pooling, no matter what you have done with it, whatever is going through that network, that pattern is encoded in sort of a DNA, which is holding all that information. And that information will come out at the other end saying, this is related to that pattern. But despite all of that, the question remains, what is it it's actually holding? What is in this grid? What is that pattern that it's holding? What is that DNA? We don't know. The answer is we don't know. And that is the problem with AI. It's still a black box. It's still a system where we don't know exactly what is going on within the system. And so Google has tried to come up with what's called explainable AI, to try and explain what the results actually mean and why they actually gave us those results. And the BBC article says Google tackles, and I've stricken off tackles because it hasn't tackled it yet. It's trying to tackle, but it hasn't happened yet. Now, with all of that said, do I think AI is artificial intelligence is powerful? Absolutely. Do I think the future is going to be full of AI products? Absolutely. Am I still in love with AI? Absolutely. And can AI take over the world, and can kind of AI supersede human intelligence? Absolutely. It's an emphatic yes. I've given you all these examples where we don't know what's happening. They're fragile, they're brittle, they're breaking down, they're not giving us results, and so on. And deep learning doesn't do what it needs to do. Convolutional networks are causing more problems than actually, giving us good results. Despite everything, AI can do far more. What is the beauty of AI is where the intelligence, it's intelligently encoding in the memory map all of the details related to these patterns. We are doing some things wrong. For example, the data hoarding. We are hoarding too much data. We are trying to use too much data. Many of you are seeing me for the first time. My face. The next time you see me partially, you're very likely to recognize me. You're probably going to say, well, that looks a bit like AI. And if someone sees me from behind, you're probably going to say that looks a bit like Anne there. You don't need to scan my entire image to be able to say that is Anne. And maybe that's one of the mistakes we're making, is we are holding on to data far too much. Maybe data is not the answer. And they do say that data is the next fuel. It's valuable. I do 100% agree with that data is extremely valuable, and it is the next fuel. The reason I say it's the next fuel is because it's the next big polluter. That's the only reason I say that. It's not because all of the data is really necessary for us to improve AI. Another thing that's also happening is because of the reliance on the data, the intelligence aspect is sort of bypassed and ignored. If someone actually touts and say, well, my system uses billions of data points and we are using GPUs and TPUs, tensor processing units, and then the question is, how stupid is your AI that it needs that much amount of data? So maybe the future is not big data, maybe the future is small data, but we'll come to that in a minute. So there are some aspects that will change and have to change in AI that will enhance the intelligence of the future products. The good thing with advances in AI, though, is that large companies are contributing quite a lot, like Google, Facebook, and Amazon. Programming is being dumbed down. There's lots of accessibility and adoption. In the sense, there's lots of data science courses, universities, kids are coming into AI, and there's lots of buzz around AI. The opportunities are this healthy investment, there's innovation happening, there's time to prepare. the weaknesses are there's no one size fits all. It's still not a precise science, and there's still a huge gap in skills, in the sense that even with current data science subjects that are being taught and where students are trained, because of the dumbing down of the programming, they're not able to look at what is exactly happening inside. And I think that kind of leads to a gap in skills that are slightly different from what can be achieved in terms of developments in AI. The application and adaptation will continue, but the enhancement of AI products may take some time. And then we have the threats, which are quick results, anticipation of quick results. One of my friends recently said that the AI stocks have tanked in one of the companies he actually invested in, because quick results are not possible with these systems. So investments are withdrawn, and then comes the big subject of ethics and regulation aspects. Okay. Let's do a little experiment to actually see how to enhance AI. So if you all close your eyes, scan the room around you, just go with me for a minute. First, scan the room around you. Look for anything that's brown at all, like chairs, tables, this sort of thing, anything that's brown. Now close your eyes. Now count in your mind how many things you have seen that are red. That's right. Your brain can't give a thing because you've been scanning the room for brown. And that's the bias there. So AI data scientists, AI engineers, whoever you want to call them, they do add bias unknowingly into how they develop the systems and how they interpret the results as well. Despite best efforts, it's still there. The best thing to do is sometimes just, at the end of the day, it's just numbers. It's people trying to find patterns within numbers. Excuse me. So, why do we need the tags? Remove the tags such as age, postcode, income, and other factors, and actually see whether what your AI does with the patterns, because that could be agricultural data from Africa. It could be the weather conditions. It could be cancer-related data. It could be anything. But at the end of the day, you're trying to find patterns within numbers. And then, so removing bias is extremely, extremely important. The next aspect is randomness. So the true learning evolves when we actually separate ourselves from the AI system. Now, it may sound really weird, but you really have to detach yourself from what you're developing for true learning to evolve. True learning is when, learning isn't a lookup table. This is cancer, this is not cancer. This is cancer, this is not cancer. No, what we want is, even when it sees something that it hasn't seen before, being able to recognize it. So learning is when you teach a child 1 and 3 is 13, 1 and 4 is 14, and you stop. And then the child goes 1 and 5 is 15, and 1 and 6 is 16, and 1 and 7 is 17. So you haven't taught it. You haven't taught the child 15, 16, and 17, but it still recognizes the pattern. And that's what true learning is. True learning really evolves. And you can tell whether the system is a lookup table or whether it's actually learning something. And for learning to evolve, you really have to have a detached view where there's no bias whatsoever. And also learning evolves, in my experience, when you have randomness involved in it. So, for example, some of the things that you do in learning, such as dropout. If you have a dropout in the input layer, that means that the dropout in the input, excuse me, I'll just take a step. So the dropout.
Sorry, I didn't want to interrupt, but I think you're stoically carrying on there with obviously struggling. Please take a moment and have a drink of water. I'm sure we can all we can all wait. You've done so well just carrying on. Yeah, take a moment, have a drink.
Yeah, thank you, Ben.
Thank you.
So randomness is when you know, it is in deep learning as well. So if you're using dropout, and the dropout is involved with the input layer, the initial first layer, that means you're actually dropping out some of the inputs going in. So this holding on to the data, this, you know, real attachment to the data doesn't make sense. So that is randomness. So add randomness wherever you can. The third one is add ambiguity. Ambiguity is where you give something that is so difficult for the system to handle. It may be so wrong that it may actually break down. So for example, you give something like x greater than 5 and x less than 5. So do something when x greater than 5 and x less than 5. So you're actually giving very contradictory conditions and asking it to do the same thing when both have to exist at the same time. It just doesn't make sense. And when you give that ambiguity, it tends to actually learn even better. The beauty is it actually learns far more. One, it goes into confusion, of course, and then it tries to figure out a way of actually analyzing it by itself. And that's when the true learning happens. And it not only learns what it has to learn, but it actually does far more than what you've asked it to learn. And that's why I can say with certainty that they will take over human intelligence. And the last one is 50 shades of gray, in the sense the results that you get from the AI system should not be interpreted as black and white, should not be interpreted as right or wrong. But you can have shades of gray in there. It's like shades of success. So how good was it? How bad was it? Is it 80% good in its output? Is it 20% good in its output? And that dictates learning again. So there are a few things you can do which are not being done currently in most systems, and also not being taught, that actually allow learning to evolve. Learning has to evolve. Learning cannot be taught. It has to evolve. And for it to evolve, you really have to sit back and let that let the system take over, let AI take over, let it find its own balance. So let's look at future trends. The Pope is very interested in AI as well, with AI ethics. Pope Francis, the Vatican, has come up with these 6 rules for AI: transparency, inclusion, responsibility, impartiality, reliability, and security, as the 6 pillars that most AI systems should have, is what they're proposing. And most tech companies have actually signed up for this, that they would have more responsible AI. Now, another future trend that I want to bring up as a case study is self-driving cars. With this, there are many things. One is a policy and law, for example, in terms of these cars. How does insurance come into the picture if an accident happens? Who pays for it? GPS and cloud computing, changing traffic rules, it's quite a dynamic system. And also human drivers. If you're anything like me, I am the worst driver on the planet. You would take for a people become car sick in my cars. So although the AI system is very good, it also depends on the human driver and taking that into picture. Now, one of the most important things is who are the consumers? Which are the countries who will actually adapt these systems? In Scotland, it's very difficult to drive around some of the hilly areas, the ups and downs, the hills and valleys, for example. And of course, ethics comes into the picture, which is if an accident does happen, you turn left, you kill an elderly woman, you turn right, you kill a child. Which way should you take? How does the decision making work? So these sort of future products are not that easy to implement immediately. And it's not just can the AI do this? It's several other aspects come into the picture, as we saw, such as insurance and law. So based on the application, the trade-offs here we have are whether it's a choice between big data and small data, whether it's accuracy or speed, whether it's ethics or impact, and a combination of those would lead to the optimal solution. And I think the future is definitely going to be small data, more intelligence. When I say the future, it just takes one breakthrough for things to happen. It could happen behind closed doors in a large company. I could be a researcher like Natalia or myself or one of you who could be investing in a company who could have that breakthrough. But it is when when these products are truly intelligent that we will reap the benefits of them. AI also has the advantage of being the great equalizer, in the sense that AI should be used for good, technology for good. I know many people who are actually trying to do things that are for sustainability, such as Jenny Marie Larson and Sarah Louise Penhall are trying to do quite a lot in terms of sustainability, the sustainability agenda. There are other things where, for example, this is a company in India, a Tata Steel plant, that has won the World Economic Forum's Lighthouse Facility award, if you like, or recognition. And this is one of the ones that has actually implemented data analytics quite successfully. But they had trials and errors, they have failed quite a lot. They had only 75% success rate, but they had made a huge impact and huge progress. But this has been going on since 2005. And finally, they're at some place where they can actually train the people in data analytics. And this is a landscape of Africa and what's going on with AI in some of the African countries. And the future also involves microchipping, for example. And this may sound really weird, but it's not that weird. You can actually have, our dogs are microchipped, our animals are microchipped. Animals are microchipped to, in zoology, we microchip animals all the time to try and study migration patterns and whatnot. Heart, paces, electronic devices within our bodies. So in the future, we would have half human, half electronics devices, and we're sort of cyborgs. And it's not an impossible thing at all. And this one here is where Finland is training the entire population in AI. It's good that some of you who are also not in AI are participating today, which is great. But hopefully all countries would become like Finland, where the entire population trains in AI, because they want all their citizens to understand what type of products they're using. So they don't expect to actually invent something, but they do expect for all their citizens to be equipped with knowledge of AI, so they end up as consumers of AI. Now, finally, we looked at artificial intelligence and what was wrong with artificial intelligence, what's right and what's wrong, what could be done, how we could enhance AI systems. In the end, let's look at natural intelligence. This is a tribute to Professor Ebert as well. It's his work. And let's see how the toad actually recognizes various things. Now, please let me know if you can't hear this, Ben, but I think I clicked on the...
Prey catching in the common toad is elicited by central nervous releasing systems that recognize prey and, depending on its localization, select the appropriate action pattern. Prey laterally, turning. Prey far afield, approaching. Prey close to the toad, fixating, and snapping. The prey sign stimulus can be analyzed in the laboratory. In this experimental setup, different stimulus objects can be selected and be moved in the plane of an arena. As prey dummy serves a horizontally oriented stripe of black cardboard. Only when it is moved, the toad turns towards it and snaps. What is the influence of shape? The simplest change is moving the stripe in vertical orientation. A horizontal stripe is recognized as prey. A vertical stripe is ignored. To analyze when the toad comes to the decision prey or non-prey, the animal is placed inside a glass vessel so that it cannot approach the object. Obviously, the toad comes to this decision before it turns. Vertical stripe in the lateral visual field, no response. Horizontal stripe, immediate response. Changing the stimulus parameter velocity influences the turning activity, however, the preference of the horizontal stripe is preserved. This also holds for discontinuous, jerky movements of the dummy. Which feature of the stripes signals prey or non-prey? Is it really the stripe orientation in space? This can be tested by means of a procedure in which black stripes on a white moving belt traverse the toad's visual field in the vertical plane in different directions. The results speak for themselves. A horizontal stripe moving in horizontal direction elicits prey catching. Faced with the vertical stripe of the same length moving in horizontal direction, the toad even turns away. The vertical stripe moving in vertical direction, surprisingly, signals prey. The horizontal stripe moving in vertical direction, however, remains unresponded. Corresponding results are obtained for diagonal direction of movement. In laboratory jargon, we speak of worm configuration if the longer axis of a stripe is oriented parallel to its direction of movement, and of anti-worm configuration in case the longer axis of this stripe is oriented perpendicular to the direction of movement. The worm to anti-worm preference results from a species common pattern discrimination ability. Does this hold also for segmented patterns? A moving small square elicits weak prey-catching activity only. Two squares closely moving one behind the other are more effective. Adding further squares clearly raises the efficacy. Extending this pattern perpendicular to the direction of movement by a small square above, however, reduces the releasing value. Adding a further square in such a position has a similar effect. It can be concluded that an extension of a pattern perpendicular to the direction of movement reduces its resemblance to prey, while extension of a pattern parallel to the direction of movement within behaviorally relevant limits increases prey resemblance.
So we saw the, can you all hear me now? Can you hear me, Ben, Claire?
Yes, can hear. I can't see your. There you are. Your video is back. Thank you, Anne. Thank you very much.
So we all
Yes,
saw
we can see.
in terms of data, what the toad actually does. It takes only certain features, and perhaps that's the way we need to look at. Maybe all of that data is not important at all. Maybe it's just a couple of features. Maybe it's just one feature that's important to recognize something. And to allow the system, the AI system, to find that feature should be one of the important areas research has to carry on. Another area is perhaps if you have a deep learning system, a deep neural network and a convolutional neural network, I don't think the convolutions are adding any value to the recognition process. If you use a DNN or deep learning and compare them for the same data, you probably will see that the results are going to be more or less the same. So we started off with artificial intelligence and we ended up with natural intelligence. And the last video that we saw is work of Professor Jörg Peter Evert in Germany. And thanks to him, and that we have a glimpse of what the toads actually see, how the neurons in the toad's brain are able to analyze the data. So hopefully in the future we'll see more biologically inspired systems as well, because biological systems are efficient. So we were talking about the definition of intelligence. With the definition of intelligence, intelligent systems also have to be efficient. It cannot have an overload of data and crumble down in a mountain of data trying to get through this heap of information and noise. So it's not about just getting something right, but how efficiently, how elegantly, how smoothly it's getting it right as well is quite important. So let's hope we hear more about developments in this area, and I'm sure we will. And on that note, I'll just end this talk, and a special thanks to Professor Ewert for joining us today, and hope you get well soon. Thank you so much. So we'll.
Thank you very much, and that was a really fascinating talk. And you've provided a very nice overview of intelligence and certain definitions of intelligence. And we saw all these latest trends in AI that you demonstrated to us. So that's all great job. Thank you so much. We've got a couple of questions here for you. So first of all, we've got here several questions and comments as well from Prabot Mystery. Sorry if I pronounce your name not correctly. So the first comment was probably on the Google slide here. Google is a machine that gives a trend rather than a prediction. This is why COVID-19 could not be predicted. So that's just a comment. Then Prabot has another question. My answer to why Amazon is still choosing something for you is that it is in the business of selling and can only sell from the existing stock. And since we have started to move with AI systems recently, is this not a case of primitive AI system? And what improvements it will bring about? So the question is this not a case of primitive AI system that was demonstrated during the presentation?
No, it's actually one of the latest systems that were adapted and implemented. I went into Amazon Science. So if you go into amazon.science, it actually tells you what technology they're using. Obviously, they're not going to give away all of their trade secrets, but I'm not sure I want to hear much because obviously the system is not that great in some ways. But it is using deep learning since 2019, if I'm not wrong. And before that, they have used other machine learning algorithms. So it is the latest. It's not primitive. Actually, there's only 7 pages of rubber ducks, for example. I've actually counted all of them. Half of them are sponsored ads. And if you delete the sponsored ads, which can be anything because they just want to sell a product, even the actual search is not giving the right items at the end. The reason I showed that is, imagine if that search actually is that, if that is about predicting cancer or non-cancer. Imagine if that is about giving a prediction about whether we have to give a loan, a startup loan to this person, or a certain credit limit to this person, or about anything along the financial side. If there's a prediction. Also, imagine if that is a dating website and they're actually suggesting a black duck to you or a brown duck when you are looking for something else. And that's how we're choosing our husbands and wives as well at the moment. So it is important to actually understand what level, and that's why I chose that example, one which is easy, one which you can go back and see. A good thing to see is that search results only for me, or is it the same results Natalia would get if she does it? Are they personalized? And we can go on and on about it and dig deeper into it. But yeah, it is the latest AI methodologies that I'm using there.
Okay, thank you very much. And there is another comment of Prabodh. Dr. N spoke very clearly and insightfully. Really enjoyed it. Thank you for organizing this talk. Thank you very much, Prabodh, for your engagement and this comment. So we've got other questions from Jacopo Emiliano. First of all, isn't intelligence the ability to solve problems?
Isn't intelligence to solve problems?
So what's the definition of intelligence that you adopted, basically?
Yeah.
Isn't it the ability to solve problems?
Well, intelligence is to solve problems. So intelligence is to do things that humans can't do in some ways. But intelligence at the moment is still taking the trend that it took in Industry 3.0, which is just automation. So the example that I gave of the doctors, for example, of cancer diagnosis, the AI system is just doing what the doctors can do anyway. But the reason they're trying to adapt it and implement it is because it automates the work for them. It makes it easier, and afterwards you don't actually have to even look at what the diagnosis is. They'll just go, the machine said that, so that is it. So stage 3 cancer, stage 4 cancers, we don't have to worry about it. The machine will get it right. So at the moment, I feel that it's not intelligence that's actually progressing, and most of the applications would be just adaptation in terms of automation of the system. So in a bank, for example, the bank manager doesn't have to analyze whether this is the right person to give something to, a loan or mortgage or something, but it would automate the process. So it would kind of switch off the human brain and switch on the AI brain. And that again takes us to smart homes and things like that. Why, what kind of generation do we want to prepare for the future? As a generation of slobs who just sit around, they don't even have to switch a light bulb, and you just sit there, and as soon as you walk into the room, the light comes on, the TV comes on, the washing machine can come on, and so on as well. The bad thing about AI in some ways, well, good and bad, is research developments follow the money. So the financial organizations have the money, the health sector has the money, and so developments go on there. But as I said, with sustainability agenda, climate agenda, equality, there's so many issues within our planet that could be solved with AI. Instead of just going, do I spend billions to trying to have an automatic car that goes down a lift and travels at 300 miles per hour or something, that Elon Musk and some of the others are trying to do. Is that really necessary? Can that billions be used somewhere else for a better, future for our future generations? But AI definitely is here to stay, and it's up to us what direction we can take it in. So if there are investors out there, I encourage them to put it into good causes, and there's so much more we can do there. One of the things, again, Natalia, it's a good question actually, because we're bringing up many, many issues, is when we have something like, recommending a loan to a person. It is one person, but if we take the rubber duck scenario, we would be, it would be the same thing where we have given the loan to the wrong person or not given a loan to the right person. And that's just one person, but in millions of customers, you could have hundreds of thousands of people who haven't been given the right product or who haven't been recommended a product. This in turn, over the years, would end up as a loss for the company. So the losses that they actually end up because of the AI systems they developed are actually so hidden that they don't even know that that particular recommendation engine has actually contributed to the loss, because how would you prove that? You're not following that person for the next 10 years to actually realize, has that person got a disease? Has gone bankrupt? Has he built a company? You just don't know what that journey of that person has been. And it's the same with the cancer diagnosis and things as well. Unless you follow that person after the diagnosis and see, so say if it's the early stage cancer, stage 1, and you actually gave a prediction that it is cancer, but you can't see it with your eye, but the AI system says it is cancer. How would you know it is cancer or not? You have to wait another few years to see if that cancer has actually come back or become bigger. And if it hasn't come back, then your diagnosis is wrong. And if it has, then it may not be just the earlier one. It could have been a cancer that has developed later on. So even in that case, it's quite difficult to prove that your AI system has actually worked. So this definition of the AI system has been successful or unsuccessful is quite a woolly area where you have to get the end result right. And that's why I say the 50 shades of gray, that interpreting the results is really important. And if you don't get that right, you can't give the right feedback to your system, and so your system doesn't learn. So it's a loop. Everyone says, oh, give us feedback and then we'll improve. You're not giving the feedback to the right system because you actually don't know what the outcome of that result is going to be over the years. So it's quite a difficult thing, And in terms of dating, if you end up with the wrong person, and it has contributed to a breakup of some kind or a marriage, you don't know if okay, let's just, settle with a brown rubber duck, just because the brown rubber duck is around. You can't tell how the results are fed back into the system for it to be developed even further.
All right, thank you so much. And of course, here we should mention that everything depends on how you define intelligence really, and how you define solving problems. So vision, pure computer vision, can be defined as a problem as well, apart from, for example, playing chess and etc. So another question from Jacopo Emiliano. What's the difference between machine learning and deep network learning? I think you can just give a short answer to this question.
Well, generally, briefly. I'm just going to give a general overview, but generally there are some aspects, some techniques within machine learning, although there is the term learning, that actually doesn't learn. Learning is where it holds information, and there are methods within machine learning where the learning is quite minimal in many ways. Deep learning, on the other hand, again, as I said, there's lots of problems with deep learning, but in deep learning, they have actually automated many things. They have made it easier for data to be handled. They have what is called dropout, for example, to drop some connections. There's other things in there that have actually been implemented, but I would see deep learning. It's just my view. It's not something that everyone else says. It's deep learning is just nothing but like a big artificial neural network. And it's just like how our brain is processing the information. It's basically going back to the basics of these processing new units within our brains.
Yes, thank you very much, Anne. And we've got here a comment from Carl Dickinson, a remark. We are building models in an attempt to replicate human intelligence. It would be good if there was a way to allow a model to naturally evolve, a new species, if you like, that is not trying to model a human brain, but something more intelligent, not restricting the model to a human brain, but to evolve. What do you think about it?
That's an excellent comment, Carl, and it is, and that's what we're trying to do in some ways with cyborgs, with half electronic humans, for example. That's probably what it's going to end up as. And as I said, many things I can tell for sure that whatever we're going to build, whatever name we give to the species, it's going to be far more intelligent than us. It's going to make up rules that the people who have built it haven't given to the system. It's definitely going to overtake human intelligence, and it's not that far, in the future. So it's just quite close. We're quite close to it.
All right. Yes, and the same comment from Carl Dickinson. Thank you for an amazing session. All right, so I think we have time maybe for one or two questions more, and one of them posed by Balaji CV. It's an insightful talk and much helpful. Do you think artificial intelligence is game changer for climate change and the environment?
It can be, but it probably won't be, unfortunately, unless more companies, more investors, the organizations such as the United Nations, World Economic Forum, and countries come together. And as we've seen with COVID, cooperation is quite difficult between countries. So I'm being pessimistic here, but it would be great if AI could be used for this. But it's difficult to get people together for a common cause. It's not that easy.
Yes, sure. There are so many powers beyond us involved in here.
Absolutely.
But anyway, well, thank you so much, and it was very insightful and interesting. Thank you for answering selective questions. I apologize for not picking up all questions that were posted. They were all really amazing and interesting. Just for the sake of time, we have to select some of them, but we will post all of them. Well, we probably send them per email because it was very kind of Anne to be ready to answer these questions after the session. And we will send the answers to all of you later on. So yeah, apologies for not addressing all of them. Well, thank you very much for joining us today for this webinar. And thank you, Anne, for the thought-provoking talk. I hope you all enjoyed the event, and thank you very much for your engagement and lovely comments and remarks. Our webinar will be available on YouTube. We will send the link to it later. And please fill in our short survey that will be sent to you straight after the webinar. You can let us know what topic preferences you have for future webinars, either generic or very narrow or specific topics, and we will be very happy to address them. You can find us on LinkedIn and online. Just search NobleProg UK, Ireland, and Netherlands, and check our broad offer of AI and IT related courses, including the courses on soft skills. Well, thank you for joining again, and have a nice day. Bye-bye.
Thank you all.
Thank you. Bye-bye.